to that are minus 2 and 0. That's why I was looking at minus 2. Okay, so 0. So as I was saying, 0 gives us a division by 0, so we need to exclude that. All right? Now this one's a little tricky. That's kind of the big interval that's part of the answer. But there is another possible answer here. Now if you wrote this down as your answer on the quiz or test, I'd give you 90% of the credit. But there is one thing we're missing. So, you know, I guess I should mention, we should always check the critical numbers themselves. Are they in the solution set? See, because if they are, I need to include them. Right? If they make it 0, we should include it, right?
So you need 0 for your negative 10?
Well, no. So these guys right here, division by 0. Those will not be in the solution set. But these 3 and minus 2, they make the expression 0. These, you know, I'll just say they give 0. They give 0 for the numerator. So if we're looking for equals to 0, that's part of the story, right? We already got minus 2, right? Right here. But we need to union three. So this is a kind of funny looking number line. So the solution looks something like this. We go minus 2 to 0, like that, yeah? And then over here on its lonesome, at 3, you got a solution. There may not be anything like this in your homework, but it is a logical possibility, so I'm talking to you about it. All right? Now, let's make full use of example 6 and example 7. I'm going to ask you complementary questions, okay? Like example 8. What if I asked the corresponding question, you know, x squared minus 3x plus 2 less than 0? What would the solution to that be? Solution set equals what? We don't need to do any more work. We can just use example 6 to answer that question, right? It's the same expression. That means it's the same number line. We have a different, you know, goal here, which is to answer less than 0 rather than greater than or equal to 0 over there. So what do we do? We do 1 to 2, and neither of them are included because we're not allowing 0 this time. Right? It's strictly greater, less than, rather. So there you go. Solution set is just 1 to 2. Example 9, I'm going to look at, you know, this x minus 3 squared, x plus 2 cubed, divided by x to the power 5 times x plus 10 squared. This time, rather than less than or equal to 0, greater than 0. Again, we don't need to do most of the work this time. We already did it for example 7. We should be able to read the answer from the number line in example 7. So what is it? So I do minus infinity, right, to minus 10. We've got to exclude minus 10 because it's a troublemaker. It gives you division by 0. So then I union with minus 10 to where? To minus 2, right? Can we include minus 2? Well, we don't include minus 2 because minus 2 is a place where we have 0, and we're not looking for that this time, right? We're looking for greater than 0. So we exclude minus 2 as well. What else then? So we've got this region here, this region here. Now we're over here, right? So then also unioned with 3 to infinity. And so there you go. That would be the answer to that one. Here, let me give you another example, which is kind of simple, but I think illustrates what's going on here fairly well. What if we were solving, say, x minus 1 times x plus 3 squared greater than or equal to 0? It's going to be just greater than 0, my bad. Greater than 0. So what are our critical numbers? Yeah, critical numbers 1 and minus 3. So we draw our number line. Minus 3 comes first. 1 comes second as we go left to right on the number line. Pick any point you like to start. I recommend 0. 0 is easy. 0 is between minus 3 and 1, right? And if you plug 0 into that, what do you get? You get minus 1 times 9, which is negative, right? So we get minuses up in here. And then you guys tell me, plus or minus to the right of 1? Over here, plus or minus? I heard a plus. Any votes for minus? To the right of 1, plus or minus? We have 1 vote for plus. One vote for minus. 1 plus, 1 minus. Someone needs to break it, Ty. As we know, math is done by consensus. Plus? 2 votes for plus. I'm sorry, it's plus. I mean, too bad someone didn't side with you, then it'd be minus. No, that's not true. It is plus because, look at this, x minus 1 is an odd factor, right? So we sign flip, minus to plus. In contrast, at minus 3, minus x plus 3 squared, right? We're not going to flip. It's just going to stay minus as you go across minus 3. Now, if you don't believe me, you can easily plug in numbers and check, right? Plug in 2. What happens? You get 2 minus 1 times 2 plus 3, which is 5. 5 squared, 25. Clearly, we get a positive if we plug in, you know, like 2. And if you plug in minus 4, you get minus 4, minus 1, right? Minus 5. And whatever you plug in here, when you square it, it becomes positive. So if you get negative, you get positive, you get negative. Yeah. So solution for this one is what? Solution set is 1 not included to infinity. Example 11, I like to make the most of each one of these kind of examples. So what if I had x minus 1 times x plus 3 squared less than 0? Very similar problem, very different answer. Very different answer. So what's the answer? So the solution set would be what? So if we want it less than 0, we want where there's negatives on the number line. So it's a little late to ask you this, but we're over here, right? The camera? Okay. It's fine. His moment of terror as he's thinking about the things I erased over here. And I'm always looking at the board, so I never see people move the camera. So, Okay. It requires trust, is what I'm trying to get at here. So minus infinity to minus 3. Is minus 3 included? It is not, because minus 3 is where we get a 0 for this expression, right? We're not looking for 0, we're looking for strictly less than 0. And then I union with minus 3 to what? To 1, right? And so there you go, that would be the solution set in this case. Any questions about this? You're like, well, at least we didn't complete the square today yet. Do we have time? We still have a couple minutes. When would you need to complete the square on these kinds of problems? You need to factor them. Yeah, let's see here. Like something like. See if I can pull something from my hat here. How about this? What if you had x cubed, don't be lazy, plus 3x squared. Oh, that's too lazy. Curses. X cubed plus 64, right? This is the sum of cubes, remember? So this factors to, that's x cubed plus 4 cubed. And we would look at our handy dandy formula sheet to remind ourselves that factors as like x plus 4 times what? X squared plus, I think maybe minus 4x plus 16, I believe. Let me just double check that. That's a 4x squared minus 4x squared. This gives me 16x minus 16x. I got my x cubed, I got my 64, we're good. Okay, so then we can solve that, for example, greater than 0. Yeah? And so let's see here. That if I complete the square on that, that's x minus 2 quantity squared, yeah? Minus 4 plus 16, which is x plus 4 times x minus 2 quantity squared plus 12, greater than 0. So what are the critical numbers here? Let me ask it a different way. Can this be 0? We have something squared plus 12. Could this be 0? It can't, right? The smallest this could be is 12. If we're only allowing real variables, all right? So that's at least 12. That's definitely positive. So x plus 4 is the only thing that can flip signs. When does that happen? It happens at minus 4. This only critical number here is minus 4. So you draw your handy dandy number line, you put your minus 4 on it, you check any number you like over here 0, for example. 0 gives you 64, its pluses over here, its minuses over there by the sign flip. The answer is minus 4 not included to infinity. So. Now, if you knew more about the cube root function, there's a simpler way to solve this problem, but we don't know that yet. So anyway, hey, that's it for today. And so Thursday, we're going to deal with absolute values, equations, and inequalities with absolute value. Make sure you pay close attention to that class. This is the next thing we're covering. A lot of people tend to get wrong on the first test, in my experience. But it's not hard.